Good morning, everyone. So what we're going to be looking today is sequences. Now, this is something that you have seen before in year 9, so we're going to go quite fast on these simply linear sequences. So obviously we know that the difference between the consecutive numbers and n is the position of the term in the sequence. So say, for example, if we had 5, 8, 11, I'm going up in 3. Previous number would be 2, so therefore this would be 3n plus 2. And this is all it is when it comes to sequences. As you can actually see here, these are only grade 5 questions. I don't want to waste too much of your time with these questions, so feel free to try one from each section for us. Pause the video and mark it. So please mark your work. As you can actually see here, they're not even asking you to work on the nth term, they're just asking you to continue the sequence. The nth term of the sequence is as we did at the beginning. So you've got 3n plus 1. That n simply represents the term in the sequence. So if I wanted the 100th term for the sequence of 3n plus 1, I would simply do 3 times 100 plus 1, so the answer is 301. Again, simple questions that you've been doing since year 9. Mainly focus on question 2, please, for us. Pause the video. Try the question. And please mark your work. Something that you might not be familiar with, but you should have seen before, is problems involving inequalities. So for this question, it says the first term that is greater than 1000. So simply use your formula, use your sequence, even your term, and find something that is over 1000. And n is greater than 143. So the first term, which must be a whole number, is the 144th term. Again, as you can actually see here, I've got all the questions. Please only try the ones that I've highlighted. So you're doing question C and H here, F, 3B, 4E. Okay, so you find the nth term, the 100th, and the term close to 100. And then try questions 5, 6, 7, 8, and 9. Please pause the video. Try the questions. And please mark your work. There's 2 ways to work out the quadratic sequence for a term, so an nth term even. So if I've got 2, 12, 28, 50, 78, I use the algebraic method, but I also will show you the method as I've got here for the table. So first thing you're doing is you're working out what the first difference should be. So first difference is 10, 16, 22, 28. Second difference is 6. Now, what you must know is that the second difference is always going to be equal to the value of 2a. So therefore, 2a must be 6. So therefore, the value of a must be 3. So that's the first piece of information. Second thing that you need to know is that the first difference is always going to be 3a plus b. 3a plus b. So therefore, 3a plus b must be equal to 10. You know the value of a is 3, so therefore 9 plus b equals 10, so the value of b must be 1. And the last piece of the puzzle is using the first term. So the first term of the sequence is always going to be equal to a plus b plus c. So a plus b plus c equals to 2. So 3 plus 1 plus c equals 2. So c must be equal to minus 2. So that means a quadratic sequence of the form an squared plus bn plus c must be 3n squared plus n take 2. And that will be how I would actually work out the quadratic sequence. Now let's see it in the form of a table. Now even if you work it out with using a table, you still need to start in exactly the same way. So 2, 12, 28, 50, 78. So you're working out the first difference and the second difference. Now the way you would actually start this question is, again, you're halving the second difference, because 2a is 6, so therefore a must be 3. So you know that the first term of the sequence is 3n squared, the first part of our quadratic sequence. So you make a table. Your table is going to have, first of all, the numbers in a sequence. So n, if n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5. Okay? So what you're trying to work out, you're trying to work out 3n squared. So therefore, what we're going to have are the following numbers. 3 times 1 squared is 3. 3 times 2 squared is 12. 3 times 3 squared is 27. 3 times 4 squared, 48. And 3 times 5 squared, which is 75. So this is what we'll be doing in order to get these numbers. And what we do is, we take this away from each other. You've got -1, 0, 1, 2, and 3. And you're simply working out the nth term for this sequence. Now the nth term for this sequence is, what am I going up by? I'm adding 1, so that'll be 1n. And if I was going back, -2. So therefore it's 3n squared plus n take 2, which is exactly what we got for the previous method. Okay, so you simply use whichever method you're happy with. Okay, I use the algebraic method. If you're happy with using the table method, feel free to use that. Now, if you want to pause the video, not here actually, sorry. You're going to pause the video now, so feel free to pause the video now and try these questions for us. And please mark your work for these questions.